Hello, financial algebra people. Today's topic is the compound interest formula. And before we discuss the formula, let's just talk about compound interest and compounding. What does it mean? Compounding is when they put the interest into your account. For that simple interest formula, it only happens once. But compounding actually happens more often than just once. Typically, things are compounded every day. So whatever interest you get that day, it's put into your account. Then the next day, it's put into your account. So the interest does add up, and after time, you will have a lot of interest in there. So for this formula, B equals P times 1 plus R over N raised to the NT power. This is what everything stands for. B is your ending balance. That's how much you're going to end up with. It doesn't just give you the interest, it gives you the ending balance. P is the same as the principal or your original balance. That's how much money you put in. R is your interest rate expressed as a decimal. I saw in today's assignment, many of you were forgetting to put it as a decimal. N is the number of times interest is compounded annually. So if it is compounded annually, you would put 1. If it's compounded monthly, you would put in 12 because there are 12 months in a year. If it's compounded daily, you would put in 365 for N, and because there's 365 days in a year. And then T is your number of years. Okay, you're going to need a calculator for this formula. So let's do a couple of examples now. I've included the formula on each example. So Marie deposits $1,650 for 3 years at 3% interest, compounded daily. 1,650, that's our principal. 3% is our rate. So our rate is 3%, but you convert that to a decimal and it becomes 0.03. N is the number of times it's compounded, and that's daily. N is 365 because it said daily, and then T, number of years, is 3. So we would do this formula by saying 1,650 times 1 plus 0.03 over 365 raised to the N times T, 365 times 3. Now I'm going to plug that into my calculator, and I'm going to enter 1650 parentheses 1 plus 0.03 divided by 365, close my parentheses, and then however your calculator does the exponent, it's going to be raised to the exponent of 365 times 3. Make sure when you do this, let me hit enter. Oh, that's not right. Oh, I didn't do divided by 365. It said 0.033365. That's why that didn't work. 1650. Well, the reason I knew it was wrong, I got an answer of 9. And if you start out with 1,650, you're not going to have 9. So let's do that over. Parentheses 1 plus 0.03 over, or I put the divided symbol, 365, there we go, raised to an exponent of 365 times 3, and we get an answer this time of 1,805.38.08. And remember, in this class, everything is money. $1,805.38. When you're doing this on the calculator, a couple things to be careful of. When you make sure this is an exponent, not times, so usually that's your up arrow like the caret, and then make sure the 365 and the 3 are in the exponent, not just the 365. I'm using right now a graphing calculator because I'm in school. At home I would use my phone, but my phone is being used to record this, so I can't use my phone. Like I said in the other class video, you can download for free a scientific calculator onto your phone, and that does have exponents. The one that comes with the phone, I don't believe it does. All right, so I would definitely go ahead and do that. Okay, let's just do one more example. It's basically using this formula. Okay, let's read through the problem. Kate deposits $2,350. Well, that's our principal. That's our starting balance, $2,350. That earns interest at a rate of 3.1%. 3.1%. Now, when I converted, I just moved the decimal point to the left twice. If you have trouble with that, you can take 3.1 and divide it by 100. It'll give you the same number. 0.031 is what I plug into the formula. The 0.0 in the front, you don't have to enter that into your calculator. Compounded monthly. Monthly is the number of times it's compounded per year. So n is equal to 12 because there's 12 months in a year. What is their ending balance after 5 years? Well, time is 5. We plug those into the calculator. It says round to the nearest cent, but we always do that anyway. So it's 2350 parentheses 1 plus 0.031 divided by 12, close my parentheses, raise it to an exponent. You may need to put the exponent in parentheses too, because you're going to do 5 times 12. 12 times 5, actually it's the same thing as you know. And I have, oh, I made a mistake. Now the reason, again with the division. Maybe my division button is a little off. The reason I know this is wrong, I got an answer of 14,000. Well, if you start with 2,000, you're not going to have 14,000 with interest. You may have a little more than that, but not that much more. 2350 parentheses 1 plus 0.031 divided by 12 exponent 12 times 5, enter 2,743. That's a much better number. 2,743.4478 with a bunch of other decimals. Rounded to the nearest cent. Cents are 2 decimal places, so there's your nearest penny. That 7 means you round that up to a 5. So our answer is $2,743.45. So you see, you went from 350 to 743, almost $400 you've gotten after 5 years. Okay? So good luck with your assignment. The formula is posted in your assignment. You don't have to memorize it. Today's assignment really is practicing plugging those numbers into the right spots and doing it correctly in your calculator. I'm in school right now. I don't have Wi-Fi, so I can't really post this till tonight, but I'll post this tonight for tomorrow's lesson, which will be due next Wednesday.